The first step to calculate the DC panel that I need for my new boat is this. Verify where should be located the DC panel and avoid proximity with the AC panel. I have a lot of experience doing wirings like this. I don't like boats where the DC panel and the AC panel use the same compartment and both of them are together. I don't like that because soon or later you can make a mistake and you produce a short. You need to make a list of all the equipments that we are going to connect together on the DC panel. Okay, I am going to install 5 blowers, I am going to install lights, I am going to install all the DC equipments. You need to make a list and in front of the list put the capacity of each equipment in amps per hour. In this particular case, the front of this panel is this. With the ammeter, the voltmeter, and the breakers, the individual breakers. In the back, it's exactly like this. This is the positive bus bar, and this is the output of the breakers. This is the voltmeter and ammeter. Voltmeter and ammeter. Right now, I am going to explain the procedure to connect each instrument and the procedure to do the troubleshoot on this panel. The next step is verify how many extra DC sub-panels will be working from the main DC panel. This is a very important information. Some boats, some manufacturers prefer install the main DC panel and that panel should be the manager of the rest of the small DC panel. Let me explain that. Some manufacturers, they have one breaker in the main panel and that breaker says electronics. When you activate that breaker, electronics, you send power to other small sub-panels, like the panel that you have on the screen, for electronics. The bilge pumps should be powered all the time without any breaker. Why? Because you need that the bilge pumps works all the time. Doesn't matter if you turn off all the switches, you disconnect all the switches, those equipment, the bilge pump, they have power all the time. Those equipments like the bilge pumps should be connected from a constant positive bus bar. A constant positive bus bar like this. This is a constant positive bus bar coming directly from the battery bank. This is a constant positive bus bar. What is the function of this? I am going to connect the bilge pumps. The bilge pumps receive the power directly from this point. The final is using a drawing tool for engineers. Try to make a professional wiring diagram following all the marine safety regulations and rules. This is very important. A professional wiring diagram. You need to give to the manager of the project and to the customer the wiring diagram in order to integrate that wiring diagram into the catalog of the boat. Use a screwdriver in order to lose the terminals and tight the terminals on breakers. Use a screwdriver, hand screwdriver. Never use impact tools like this. If you try to use that one, you damage the head of the screw and you destroy the plastic on the terminal, or you destroyed the breaker, or you destroyed the relay. Never use impact tools. Exactly the same when you try to tight terminals on the relays. Use appropriate tools. Use the properly range. Remember, previously to this video, you calculate how many breakers you need in your boat, the capacity of those individual breakers in amps per hour. In some DC panels, you have a main breaker. In big panels, you have a main breaker and the individual breakers. In this small panel, I only have the separate breakers. I don't have main breaker. All right. The first step is calculate the gauge of the wire coming in with the power. from the battery switch selector. This cable is protected with a fuse. This cable, according with the capacity in amps, is protected with a fuse. And this is the fuse. This is the fuse used to protect the panel. Now, for example, I want to know the breaker number 2 is the breaker for the blower. I want to know what is the consumption of this blower when the blower is running. I am going to use my ammeter. Okay, I am going to put my ammeter here, and in this moment the breaker for the fan is off. The fan is not running. What happened when I close the contact on the breakers? The fan starts. Alright. In this moment, the contacts for that wire, the positive wire of the fans, are open in this point. What happened if I connect my ammeter right now in between this point and this point? Of course, the fan starts and I read how many amps is the consumption. 2.4 amps. Once again, you see that the consumption in amps, DC ammeter, you see 10 amps. That's the consumption of the fuel pump, you remember? And you remember the other one, the blower, the consumption is 1.2. Exactly, excuse me, 2.4. 2.4 plus 10, 14, plus the lights. That's the consumption of the panel right now, around 15 amps.